So welcome to Step Change's Q3 Sunday safety session. My name is Alan McIntyre. I am one of the health and safety program managers working for Step Change, and I'll be hosting today. So just some rules just around the safety session today. In the Teams chat, if you're able to, could you just type in your worksite name and the number of people if there's more than one person watching and attending. If you do have any questions throughout, please just type them into the Teams chat and we'll stop and we'll answer them. There is a safety movement video that we're going to show, and just bear with us with regards to the connection. Thank you very much, Craig, from 40s Bravo, 3 people, excellent. And then we're going to have a quiz as well. So if you do have access to a phone, a tablet, or a laptop, there'll be a link, a URL, or a QR code that you'll need to scan and to set up to attend or to go through the quiz once we get there to that point. Please keep your microphones on mute. We are recording today's session. I think, yes, no, we are recording today's session, and it'll be uploaded to our YouTube channel after today. And as always, with feedback, there will be a link at the end for you to provide feedback on today's session. Please try and take the time to give us some feedback. It helps us improve, and hopefully make these sessions a bit better in future, just to keep improving. Okay, so we'll get going then. Next slide, please, Julian. Okay, so we'll do the welcome introduction. There's a safety moment film we're going to show you. We have a guest speaker today, Alan Smith from Drops has come and is going to give us a presentation on Drops. So thank you very much, Alan. We're going to have a Q&A after that session, if there's any questions for Alan at that, and then we'll have the quiz and just a bit of a roundup of what's coming up, what to expect in Q4 from Step Change and safety events and things like that as well. And then we'll close at that stage. So it's just a reminder for anyone that's not aware, we have quarterly themes in Step Change. Now these won't change they're the same every year. However, the detail of what things we're focusing on, what resources are going to be produced, we sort of provide a bit more detail, go into a bit more detail within each one of these scopes. So Q3, the moment's safe lifting, working at height, preventing dropped objects. And moving into Q4, it's going to be well-being and work environment. Okay, next slide, please, Julian. Okay, so just an overview. So what our overall Step Change's overall mission is to prevent incident and injury within the energy industry. And how do we do that? Well, active leadership, member collaboration, and workforce engagement. So sharing of knowledge, incidents that happen, learning from them, and hopefully preventing them happening in future. So we have a number of work groups that cover a variety of different topics: human factors, lifting mechanical handling, major accident hazard, understanding process safety leadership, as you can see, site visits, which does exactly what it says on the tin, provides a set of guidelines for site visits. Sharing and learning looks at sharing knowledge between members, so things such as, well, incidents and things like that, and learning from those. Workforce engagement, again, does exactly what it says on the tin. Safe working essentials, so that is our suite of sort of management system tools that we have. Guidance on sort of pro formas for risk assessments, toolbox talks, after action reviews, safety observations as well. And that's free to all our members. You can use them as a template as they are, or you can use them, the template, and change it to whatever way you see fit. Well-being, and also the aviation side of things, helicopters as well. We also have a number of networks that we operate. The Safety Reps Network, focal points is the focal points from our members, and also the relabeled Site Managers Network as well, which was the YM's network. If you are interested in any of these work groups or networks, just get in touch with us through our website or info@stepchangeinsafety.net. Okay, as I said, Q3 is safe lifting, working at height, preventing dropped objects. So that's our theme at the moment. That's what we're focusing on with regards to our resources, what we're producing. Things such as safety moments, posters, guidance, lift and mechanical handling guidance, for example, and then interactive resources, as you can see down there as well. So we just have a safety moment video we're going to show you just now. That's been produced by the Sharing and Learning team.
Falls from height are consistently the leading cause of workplace fatalities in the UK, with 40 people losing their lives at work due to a fall from height in 2022 to 2023. Latest figures from the Health and Safety Executive show that falls from height were responsible for a third of all workplace deaths last year. That's up from a quarter the year before. Use your toolbox talk to ensure your team understand the hazards, the harm they can cause us, and how we can control them. By continually dynamically risk assessing our environment, we can remain spatially and situationally aware whilst identifying any new hazards that have arisen due to changes in circumstances. We can prevent potential injuries to ourselves and colleagues by rectifying and reporting any unwanted conditions we observe. Reporting unwanted conditions allows our organisations to act on them and communicate any applicable learnings. Did you know? The standard industrial safety helmets used in the UK meet EN 397, which primarily provides protection against falling objects. When working at height, where the risk of falling or swinging remains, the standard industrial helmets do not provide adequate protection from front, side, or back impact. There is no specific European helmet standard for work at height. Standard EN 12492 covers helmets for use in mountaineering and includes protection from risk of swinging and repeated all-round impact. When working at height, where the risk of falling or swinging remains, a safety helmet meeting standard EN 12492 should be issued or worn. Harness on, helmet on. There are safety helmets available that meet both standards. It is the responsibility of employers to provide individuals with the adequate PPE required for the task, based on risk assessment and considerations of hazards. It is also the responsibility of individuals to use the PPE properly, following training and instruction from employers. Intended for different environments, the standards each have their own design and performance requirements, some of which differ from each other. As PPE is our last line of defence, we need to ensure it is suitable for the task and hazards. Identification of the adequate PPE should be made via a task risk assessment. To summarise, industrial safety helmet EN 397 covers work on the ground, tested to protect the wearer from impact of dropped or falling objects and penetration from sharp or pointed objects. Flame resistant and protects against molten metal splash. Chin strap releases at a minimum of 150 newtons and a maximum of 250 newtons. In case of entanglement, it releases to prevent strangulation. Mountaineering helmet EN 12492 covers work at height where the risk of falling or swinging remains. Tested to protect the wearer from impact of dropped or falling objects and penetration from sharp or pointed objects. Tested to protect the wearer against repeated impact from top, front, sides and back. To ensure the helmet stays on in case of a fall, the helmet is equipped with a chin strap able to withstand a load of 50 kilograms for 2 minutes, so releases at a minimum of 500 newtons. For helmets meeting both EN 397 and EN 12492, pay attention to the chin strap. Safety helmets meeting both standards have a chin strap system in place which allows the user to switch between the two standards depending on the requirements of the task. There is a good chance the helmet could be used in the wrong setting due to human error, especially if constantly changing from one setting to the other. Industry suggestion or consideration: the highest risk is a fall from height. Therefore, best practice would be for the strap to remain in the EN 12492 500 Newton settings. This would reduce the likelihood of it being incorrectly set and being removed from the wearer's head during a knock or fall. To support the risk of snagging, when waiting for the EN 397 industrial use, the wearer can unclip the chin strap. Remember, PPE is the last line of defence, as it is designed to protect the wearer after they have come into contact with a hazard. The most effective control is to physically remove the hazard. The first consideration for work at height should be: can the work be carried out from the ground? How do you know you have the correct PPE for the job? When checking your PPE, including fall arrest equipment prior to use, what do you check for? When engaging with work colleagues, what aspects do you discuss around PPE requirements in your toolbox talks? Play your part.
Great, thank you. So a safety moment there, looking at the use of correct PPE, something to think about before you're working at height activities there. So that's available via the website as well, if you guys want to share that with colleagues who maybe aren't here today. Okay, so we're going to move on now to Alan Smith from Drops. Alan's going to give us a talk today. Thank you very much, Alan, for coming, and I'll hand over to yourself.
Well, thanks very much, Alan. Thanks, Gillian, for the invitation. So my name is Alan Smith. I represent Drops. Well, it's been 26 years since we established Drops, and of course many of you will be aware of the concept, the branding, hopefully this book as well. But that's where I kind of wanted to start, because I think Gillian had said the focus being on dropped objects is how do we as an industry prevent dropped objects. It's a tall order to prevent all dropped objects. I don't know if we'll be able to eliminate them all, but of course the major focus is on the attention to the detail around eliminating that risk of exposure to personnel. So I wanted to focus on reliable securing, because for me, over the years, with the book now at revision 4, there's a lot of information in that I believe that we can all apply. Hopefully I'm going to be able to share my screen. If not, I don't think is everybody can see that. Does that come through, Alan? Does it say reliable securing on the screen, Alan?
Yeah, I can see that.
Excellent. And that's basically what it is. It's best practice recommendations, functional recommendations for the securing of equipment and tools at the worksite. Interestingly, we've just had a little briefing on hard hats. And of course, I mean, even hard hats have the potential to be dropped objects. Again, how do we secure them correctly? There was a lot of themes in that first video there that kind of gets you to think. Everything that we have, everything we use, if it's not essential, we eliminate it. If it's something we can change or do differently, we'll focus on that. But when we're looking at essential equipment, essential lifts, essential activities, we have that opportunity to identify with potential dropped objects and ensure we secure against them. So I'm just going to flick through my slides. I've got quite a few slides here. So as I'm talking, if there's a little bit of a delay, hopefully it will catch up. But the principle of Drops is it's across many industries. There's over 200 members, mostly oil and gas, but there are other areas. But that's the main objective. In fact, it's the last one I like to focus on: a second nature prevention strategy. In that everything that we do, we're always aware of that potential and always take the time out to talk about it. Of course, we've learned from consequences. It's worth starting off with this one. I mean, dropped objects, like falling from height, they do harm and they do kill. A number of our high potential incidents are dropped object related. But Although it's primarily a safety focus, there's always the other consequences to consider: the damage to equipment, the environmental incidents. This is a barrel lifter, an old style barrel lifter, where the barrel it failed, the barrel dropped, and we had a spill. And of course, reputational damage as well, whether it's small items, large items, pieces of structure. The reputational damage and the damage to the business is considerable. Thinking of exposure, I thought I'd just take lifting as an example. And you think usually dropped objects during lifting? Well, it could be what you're lifting. Here we have a construction site where these fan tubes are being lifted in a fan tube tray with no ends and not being secured. Hey, the tray was off balance and all of the fan tubes fell out, narrowly missing the driver. Now, believe it or not, the driver survived. But with this, you think, well, lifting, it's not just the load that we're lifting, the parts of the crane to be considered, the structures and supports that we use around cranes, lighting, particularly that the pivoting light on the crane boom. These all have potentials to become dropped objects. All of the ancillary items, even the tools that we use to maintain and repair cranes. And then, of course, every now and again, there's a complete surprise. This is a crane boom indicator, which again relies on gravity, swings around. The more it swung, the more the bolt wore, and it fell to the deck. Even the nuts and bolts, and I'll kind of come back to this when we start to talk about the hierarchy of controls again, the concept of all around us, there are heavy items, but there are some small items too. So a consideration for fastenings. Because if you think, again, it's something we're all familiar with, the concept of the drops calculator, that awareness of fall energy, the potential for impact, and as a result of that impact, an injury. If you take, in this case, a 200-gram bolt and drop it from 30 meters, you're looking at, you're on the verge of what you might call a minor injury, or the medical treatment case, and a major injury, a lost time injury, an injury that would result in you potentially spending the rest of your life in a wheelchair. We're talking about blunt force impact here to the human body. One thing to bear in mind with the drops calculator is it does not factor in sharp items. Sharp items can puncture the skin. I know, again, we talked about hard hats earlier there, but there's a number of statistics that show you're not always struck on the head from dropped objects, and they're not always above your head. They can be all around us. So an understanding of dropped objects, what should we talk about in the work site? Do we talk about gravity? Do we respect gravity as a hazard? We've got these two definitions, and rather than waiting until we have an actual incident to decide which of these it is, it's an opportunity in our task plans and our risk assessment and our toolbox talks to take that time out to look for items that have the potential to fall under their own weight, or as their weight changes. For example, if they start getting wet, or there's a build-up of materials. When gravity takes over, hey, it's a static dropped object. We can deal with those. We can make sure things are secured, and we can monitor the work site and get that understanding of how we are responding to gravity on its own. Dynamic dropped objects, well, it's just that, isn't it? An applied force that then triggers the release of gravity, whether that's a collision or whether that's continuous dynamic loading, pushing things to the extreme. It could be during transportation or lifting, cyclic loadings, as I say, suspended equipment, for example, environmental factors, things being blown over, even humans interacting, intrusive maintenance, rotations, unscrewing things. What about the common causes of dropped objects? Well, here's a list, and this list appears, as do all of these definitions, in that reliable securing booklet. Take the time out to read through these, because these are all kind of captured from all of those shared learnings for the past 26 years. And there's probably way more than this. Because the number one is failure to see the hazard in the first place, but failed fixtures and fittings seems to be, again, one of the most common from those that have an established drop scheme. And that could be caused by corrosion or vibration, non-OEM parts. So again, not following the manufacturer's recommended practices or specifications. Again, there was a mention of human factors earlier, or perhaps the consideration for error traps. People make mistakes. Let's start to identify why that might be. Is it an unclear procedure? Have we got enough time? Is there enough people to do the job? Do we have the correct competence? What about the working environment? Do we have enough space? And also that human trait that we have where, if we haven't got the bits, but we need to get on, sometimes we do modify, sometimes we do change. And really, we should stop the job. Because again, if you go back to that kind of common cause, it's that failure of our securing that results in dropped objects. Now, the hierarchy of control model is an interesting one to consider. It's one we're all invited to use. We use the step 7 process. Again, step 1, this is where we should use this and always refer to this. Again, I'm going to start at the top. Eliminate the hazard. If it's electricity, we can isolate it. If it's pressure, if it's temperature, we can typically start to think about physically removing that hazard. But if we identify with gravity as a hazard, that's the first opportunity to understand that gravity is a constant. You cannot switch it off, of course. It has this amazing ability to, as things fall, to accelerate. By the time something falls 10 meters, it's 10 times its size, and then it just keeps on accelerating. It's being drawn to the center of the earth. So we have to identify with what could drop, or indeed the energy source that could trigger the dynamic dropped object. Eliminate that. Of course, substitute. Take a simple example, a metal sign. We've got plenty of those. If we don't look after that, or if it's struck during activities and it's worn or it's corroded, typically it'll drop. Well, can we replace it? Can we change it for something else? Well, yeah, we can paint it on. There's lots of good examples, but do we take the time out to look for opportunities to eliminate and substitute? But the next one makes perfect sense, doesn't it? If we're going to secure things, we're going to make sure they are engineered. Engineer the hazard out. Well, let's go to design. If we're going to secure things or lift things or suspend things, let's understand that principle of reliable securing. Let's also then consider additional securing, maybe even consider further engineered controls, even things like toe boards and physical barricades around our guardrails, or creating working habitats. Some of these hierarchy of control models. As an industry, I don't think we can live with a model long enough before we start changing it. But this one makes sense to me, is to kind of maybe just split that one out. Isolate people from the hazard. Now we're aware of the hazard. We've done everything we can with engineered controls. We've got a clearer idea of exposure. Let's think about isolating people. So the obvious drop zones, red zones, restricted access areas, but also we've got the opportunity to rethink how we work. Perhaps even automating or looking at remote controls. Administrative controls, I always tend to focus on this because this is everything from our checklists right through to the permit to work process, all of our procedures, the way in which we work. Well, we can always look at ways of improving that. But there are elements in here that include codes and standards and manufacturer specifications, an important part of drops. PPE. Now, I would usually just say, yep, protect people with personal equipment. It's the last line of defense. But when it comes to dropped objects, there's not very much protection that's offered by a hard hat. When you start to think about fall energy in joules, as in the measurement of fall energy or measurement of energy, once we start moving beyond 40 joules, or an example that I should have actually put in if I'd known about that initial video, is what happens if, let's say, a 200-gram bolt drops from 27 meters. When you calculate that and multiply it by 9.8066 meters per second squared, you get 58 joules. Now, 58 joules, that's not going to damage a hard hat. But goodness me, it's going to give you a significant impact that's probably going to affect everything from your skin, where the cradle of your hard hat compresses, and even the top part of your spine. Once we get up to about 85 joules, hard hats start to show the sign of impact. Once we get to 110, 120 joules, hard hats tend to start to fracture. 140 joules, well, that's when your hard hat is no use to you at all. So always beware when they're telling you about the protection you get from hard hats. Even with small items, particularly where we're working, in environment where we work, we take a bit of a step back and have a think about, what kind of protection do we get? We need to start to think about how drops focuses on this. A typical drop strategy: let's generate awareness, let's identify our exposures, let's identify our equipment inventory. What do we have around us? Is there anything here we can eliminate and get rid of? Anything that's redundant that we can remove? What we have left, let's use this information to confirm it's secure as it should be. Let's make sure that it's repaired and maintained. And then let's make sure we inspect it. So there's a whole survey and inspection concept that comes with drops. With that incorporates what we call the risk ranking, an identification of where things are, the exposure, the condition of the equipment, and we have the opportunity to respond with what we call safety securing devices, safety nets, safety wires, etc. Clearer idea of what could drop, that means we can identify the cone of exposure. So we can create these drop zones, or as a minimum, start to restrict access if we need to. Because it's what we do with tools and equipment at height. That's best practice, create an inventory. It's not just tying tools off, it's understanding everything we're taking with us. Same with lifting and transportation. Nothing gets moved until we have that inventory, until we have clear instructions on how to manage that. It needs to be part of our lift plan. And then we've got better planning, better risk assessment, better management, better governance if we stick to this strategic approach. So what I want to do is just flick through this very quickly. But I want to make sure that you have access to this book. It's available online. It's free, but there's many different sections. But there's right up front, the opportunity for us to all have a basic understanding of the types of fasteners that we use, the different challenges you might have with using them. As again, you can see the alerts that are presented next to each. Things like, the nylon insert nut, the recommendation, it's a single-use item. You start to think, I understand why, because I understand how it works. So it is that, it's the opportunity to look at how everything is secured. Is it OEM? Does it match the manufacturer's specification? Who looks after it? What is it that I've got to do to monitor it? And what kind of advice or what kind of cautionary statements can I introduce into my own inspections, or indeed getting involved in repair and maintenance, is to confirm that we are following best practice when it comes to fasteners. Because again, what we find is throughout the supply chain, sometimes the concept of design might be lost because it may be legacy equipment. It may be quite challenging to actually find out who designed it, who made it. How was it transported here? What was it subjected to? And again, throughout different task steps, what is our exposure? Well, there's always gravity, but then gravity and movement, gravity and vibration, gravity and all of those things, plus the natural environment. There's the potential at each of these steps. But it's opportunity for us to take a step back and start to think, if I'm accepting things or I'm working with these task steps, how do I verify that every single item is secured? Well, that's the opportunity to confirm that it is secured, but also respond to remaining risk. That's where we have things like the safety nets and meshes and safety lanyards and tethering systems, even temporarily introducing a tethering system, particularly during maintenance. I'm sure the one part of drops that you're most familiar with is the concept of that tool cabinets or tool boxes or tools designed specifically for use at height. Now, there's a lot of best practices here, but the one thing that we don't necessarily recommend is for you to go and just buy random tools and attach lanyards, because when you look at the tools and look at the tool kits that we recommend, well, almost every tool has been carefully considered. The tool, wherever possible, has been engineered into one piece, into a composite. And if not, anything with multiple components will have positive lock-on. And again, the system works because we maintain an inventory. We have an inventory so we can check all the tools have returned at the end of the shift. We have an inventory so we can inspect the tools perhaps every month. And even a shadow board so that if we see a tool is missing, well, we can confirm, is it on the inventory? Is it out of service? Or what about the logbook? So every shift we maintain a logbook. Anybody takes a tool, they sign it out and they sign it back in. And that is verified by the area authority. Of course, recommend use of tool bags and lanyard systems. because that is ultimately that response to the remaining risk, and a recommendation for 100% tie-off. And not just at height. Have a think about how this may work in deck areas. We're not necessarily at height, but all of the equipment around us, well, it's going to be lifted. Well, we inspect things before we lift it. Yeah, but we're just people. We might make that mistake. But if we can start to think about how we manage tools at all work sites, dynamic work sites, then we can certainly start to reduce the potential for tools to be left. So if ever you need some help with this, or if ever you need to explore this, of course, we've got some great members that part of Drops that would be delighted to show what we have. But the one thing, if I focus on the top right, you think of your standard socket set, or if you spend a bit of money and get a nice Barco set, if you want to remove or change out the socket, there's a button on the top. Now, even that button, that's not good enough. It's not a way of retaining that socket. We will typically have a lanyard on the wrench, but if that tool is dropped and the tool swings and strikes the structure, there's a potential for the socket to come off. Or indeed, if that little system starts to fail or wear, you could be using the socket set, and again, your wrench handle, that's secured to your tool bag, but the socket isn't. There's a potential for that to spin off. So you look at the tools suitable for use at height. You identify with multiple components, and you identify with positive lock-on features. So it kind of makes you think about all different types of tools, and again, how you register that, how you maintain that. But Reliable Securing booklet is more than just that. It gives us an idea of what to talk about, what to consider. In particular, this page is great. What can we introduce into our discussions in that risk assessment, or when we're planning the task? Well, everything from environmental factors to things that, what do we inspect, what do we look out for, and then that cone of exposure. So if it was to drop, where would it go? Because things don't necessarily always fall straight down. The wind can affect them, the trajectory, again, if it's pushed off or nudged off, but ultimately everything wants to be pulled to the center of the earth. But what about the deflection? Well, when we've got the calculator to help us with that fall energy understanding. And it doesn't take much for us to kind of go beyond this green section, which we call slight. But remember, that green section is a first aid, if you like. That green section, as you get closer to the yellow, is an ever increasingly painful bruise, contusion. You might argue that's within skin resistance, but it's still an unacceptable injury. Once we start heading into that yellow and into the orange, this is really what you might call realistically recordable or worse. You might say this is based on the average human being. You could say the majority of us might be able to take that kind of hit, but no, it's not acceptable. And it's certainly something where we have to realistically think, with this rapid increase in acceleration, exponential increase, there's that real potential for us to quickly move into that, a major injury incident. Deflections. Well, there's actually a tool that we've got. If you look on our website, you look in the calculator section, there's a deflection tool. So if you know the height that you're working, and or you start to think, well, if I did drop something and there is a potential for a deflection, because you may well have your tools secured, but what about the nuts and bolts that you're removing, or the cover panels? Have a think about where it might fall. Have a think about deflections. Because if you do hit the sweet spot, as you can see on this graph here, there's a potential for the item to travel certainly the distance that it's dropped, potentially even further. On our installations, but by the time it gets that far, it's either going to hit a bulkhead or hit a wind wall, or potentially, go straight through, past that deck, and then drop to the next deck below. And as it's dropping, of course, it's accelerating, and they can hit something else. And then you start to think, well, I want to focus on how I can prevent this from happening. You can certainly use this to consider your barricaded area, but realistically, this should be the opportunity to think, how will I engineer this issue out? Of course, concluding on the controls that we do have, the controls that don't prevent dropped objects, but certainly eliminate the risk of exposure to personnel. Now, this is obviously a rig floor, very dynamic area, lots of things moving around, lots of suspended equipment, but in every area, the opportunity for us to manage who's in and who's out, only those required for the task, making sure that, hey, everything is controlled under some kind of plan or a permit, but understanding what that exposure is, an understanding of what it is that could drop and why it could drop, and then identifying the step back areas that you're gonna go back to. Also remembering that tasks change. So again, drilling, you've got kind of standard tasks, routine tasks, and you can have that set area. But then as things start to change, for example, tubular handling, as you do on the deck, you start to think, well, we know about the crane radius, but then you start to think of potential for dropped objects. Perhaps that area starts to grow and becomes more dynamic. Of course, we don't stop there, do we? Because we've got this whole supply chain to consider. Securing of cargo coming out, securing of cargo going back. Still a major area of concern. This book helps us identify how different types of equipment, the standard equipment that we use, a generic checklist isn't always suitable. Make sure you start to identify with what it is that's inside that certified unit with the forklift pockets and all those potential spaces for loose materials. Have a good look. Understand how that equipment's been used, how it might have been maintained on deck. And make sure that in our inspections we cover everything, even down to this inspection plate, which, again, that's a sharp plate. I've got plenty of photographs that would show that sharp plate, what happens when that drops, because the rivets were the incorrect material, with low-grade zinc, perhaps, securing a stainless plate in an offshore environment. Hey, we're going to get corrosion. The plate's going to fall off, and then it becomes a ninja Death Star. So, of course, we have best practice. We have lots of documentation. We have a backloading program. We have an opportunity for us to take ownership that we have checked this. We have identified with what it is that could drop. And again, many more administrative controls that we continue to develop, including things like, well, when you hand over from maintenance back to operations, well, do we have an inspection book that we can follow? Can we confirm that all of the securing methods are as they should be? Nothing's been changed, nothing's been altered. We've got the torque tables and the materials and the tensile strengths, all that information is available to us. And then again, when we accept equipment before it's installed, again, have we all had a good look? Have we all considered that dynamic and static potential? Have we thought about collision checklists? Have we thought about where we're putting it and how that location may indeed present different exposures? For example, vibration. Do we have an inspection program? Of course, it's mandatory in drilling, but there's no harm in looking at the best practice that we have, breaking areas down into manageable zones, and then looking at equipment families. If you want help with that, recommended practice takes us from design through to decommissioning. But reliable securing, well, that gives us pictorial references, considerations, worksite prompts, and much more. The opportunities for us to take that step back and think, well, I can use that book as a training aid. I can study maybe a page a week. I can build presentations around it. All that information is freely available. We provide the help and support, of course, if you need that. But then there's a lot more. There's a checklist we can use. There are prompt cards that we have available. Now, all of these are available through the Drops website. And of course, Step Change being associate members of Drops, you'll probably find that in conjunction with all of Step Change's drops object prevention support and campaign material, well, you've got all of this too. All of the things we've ever built, all of the campaign material that includes posters, awareness, training, reliable securing booklets, guidance and best practice on all of those recommended practices. There's templates as well so that you can make it specific and customize it. But this book I find is probably the best. And a PDF, well, that means you can grab the pages, you can make images. You've already got a training campaign right there. So what can we do to prevent dropped objects? I'm sure you're all thinking, well, I can respect gravity for a start. I can maybe understand gravity now. I can start to identify potentials for elimination. Maybe you still got to plan that. Sometimes it's not the case of just getting out there, performing a hazard hunt and sweeping up all of the loose materials. No, again, take the time out to understand what it is that you are collecting, because there may be learnings in that. Make sure we walk through the task. lots of best practices there, particularly around human performance. So let's start to think about where we are using gravity, or where gravity may be released. If engineered controls is the most effective after we've eliminated everything, our essential equipment, engineered controls, well, let's understand those. Are they properly installed? And then how can we inspect them, particularly through dynamic task steps? And the one in the red, well, this is again something we promote. If we have that basic understanding of how things are secure, and we understand how things are moved or how they are lifted, well, we can question the robustness. We can actually start to question the engineering. That means we have that opportunity to look at what DROPS presents, what the DROPS members have presented, what the DROPS community has learned over the years around engineered controls that we would describe as the primary fixing method, that first method of securement. Is it bolted? Is it fastened? Is it tied down? Is it tensioned? Is it clamped? And then appreciating that it's exposed to vibration, other forces, so we look for secondary retention. So secondary retention is a locking feature. So it's a locking washer, or perhaps a lock nut. There's lots of different types. There's over 80 different types of lock nuts. Integrated secondary retention. A split pin, that's secondary retention, a second engineered barrier. But single action devices, a standard nut, for example, or anything that operates like a standard nut, like a thread protector. If there's only one method of securement, well, and there's no secondary retention by design, then our risk has increased. We can respond by adding safety securing, like a tethering system or a net, but sometimes that's not practical. But what is practical is continual verification that we inspect, and confirm that everything remains engaged. And we do that throughout the life cycle, and an understanding of all those different exposures. Got to share best practice, and that's what we're doing today. And always be vigilant, because you start to read all of the alerts that we have. You'll be surprised at some of the dropped object incidents. But then when you read through the underlying causes, we go, oh, of course, yeah, we didn't see it, or we didn't talk about it, or it was a complete surprise, but now we understand why, because the mistakes were made earlier on, or it's legacy equipment, or we had incompatible materials that led to corrosion. But we know how these things happen. So they can occur anywhere and at any height. Number of injuries from low-level suspensions, or even think about jacking your car up to change the tire. It's important that we think about removing the tire or the wheel. It's a heavy item. You drop that, it bounces. You drop that on your legs, it can be painful. If the jack fails and the car drops, well, you can imagine. So look out for those low-level potentials too. Look out for them. It's not just the materials and the equipment that we suspend or secure. It could be your next task step where you have that potential for a dropped object. So get involved. Share best practice. Have a good look at what we have. There's a website full of resources, and in conjunction with Step Change and, of course, all of our global chapters, there's a continuous program of learning. So I hope that's kind of refreshed your minds or given you some ideas. But for me, thanks very much for your time. I wish you a future free from dropped objects. Thanks, Alan. Thanks, Gillian.
That's great. Perfect. Thank you very much, Alan, for that. Really thinking about, drops and how they apply to our work site, prior to the task, dynamic risk assessments at all times, after the task as well, and what, could potentially be a drop. So yeah, that's great. Thank you very much, Alan, for that input there. If you do have any questions at all for Alan, could you please put them in the chat, and we'll see if we can get them answered before the end. I know we're running slightly over time. We're going to go straight onto the quiz now. So if you do have your phone, laptop, tablet, go to Kahoot or scan the QR code, or go to www.kahoot.it and put in the number. That should log you on to the quiz. Just give you a minute or two to do that. Got two on just now. If you can't join, if you're not able to join the quiz, just put it in the chat as well, please. It'll save us waiting around. Okay, so that's Craig saying he can't join at the moment. It's fine, thank you, Craig. Okay. Excellent. It's 4 on now. 1, 2, 3. Just waiting on one more. Let's leave it one more minute and then we'll get going. Okay. Okay, I think we'll just get going. Unable to join. Okay, that's everyone that's on just now. So yeah, thank you for that, Tom. Thanks, Tom. Thank you. There'll be a number of questions, and you'll have 30 seconds to answer the question, and we'll have a scoreboard at the end.
The dynamic dropped objects can be caused by environmental factors such as wind, rain, snow, ground disturbances, helicopter downdraft. So pick as many of these as that apply and then press submit. Six seconds. Okay, so the answers were wind, ground disturbance, and helicopter downdraft. Rain and snow could affect also if there's a build-up of these and bring about a drop. On the scoreboard, look like, oh, no score for this. That's odd. I hope I made this.
Kenneth Barkley's having connection issues. That's okay.
I'm hoping these have got scores. I hope I've done this right. Next, we'll find out soon. PPE is the least effective control measure. Put these in order from most to least effective. So you've got to slide them up and down. Isolate, engineered controls, substitute, and eliminate. So you've got to like hold that and slide them up and down. So you got that right. So the order is eliminate, substitute, engineered controls, and then isolate. Oh, here we go. We've got some on the leaderboard now. So Buzzard currently at the lead. So you get points for getting it right, and you get points for getting it right fastest. Which of the following engineered controls or barriers could be described as secondary retention? We've got wing nut, locking washer, split pin, a safety net, a nylock nut, or a tool tether. So pick as many are correct and press submit. Okay, let's see what we've got. Locking washer, split pin, and nylon lock are all correct. Buzzard still in the lead. 2 more to go. Which of the following statements regarding selection and use of tools at height are correct? Keep a register of all tools taken and returned from the tool kit. All tools must have documented attachment points for tethers. Toolkits should have an inventory list of all items. Any tool can be tethered if you use a certified lanyard. Consider every item taken aloft as a potential dropped object. Correct answers are there. I'll just skip through because we're running short of time. Okay, Buzzard's still in the lead, but Mariner A coming up into second place. Last question. Which of the following red zone rules are correct? Every task must have a plan. Only persons required for the task may enter with approval from the area authority. All personnel in the red zone must wear a red hat. Minimize exposure. Identify step back areas. Red zones may be extended dependent upon the current operation. So which of these rules are correct? Okay, you've got the answers there. Right, here we go. Who's the winner there on the podium? Boomy Armada in third place. Second place, Mariner A. Third place, Buzzard.
Well done, Team Buzzard.
Done.
Okay, guys, so we will just go through, there's just a couple of events I want to talk about, and then some feedback links, and we can get you on your way.
Oops, hang on. Mm.
36, that's it. Okay, so quarter four, what to expect. We've got our wellbeing and work environment theme, and we're going to be producing some resources, safety moment, film, posters, and there's also an event which is dedicated to occupational lung disease awareness, and that's on the 6th of November on the Beach Ballroom in Aberdeen. Also, another safety moment looking at narcotic effects of hydrocarbons, films and poster campaigns, and also another overall well-being event. So that'll cover mental health, nutrition and lifestyle, physical health, and the work environment. And there is a big event organised for the 13th of November, also the Beach Ballroom in Aberdeen. You can register for those events via the Step Change website. The next Sunday safety session is 24th of November on Sunday, 3 o'clock until 3:45. And we have two pretty big events coming up, not this coming week, but the week after. We've got our Safety Reps Forum event all day on Tuesday, 24th of September, Union Kirk Aberdeen, and also the Site Managers event, also Union Kirk Aberdeen, on Wednesday, 25th. And there is a drinks reception on the evening of Tuesday, 24th. If you're interested, there's still spaces at these events. There's lots of really good speakers and interactive material, including an interactive theatre production that covers the incidents with regards to the Boeing 737 MAX incidents. So some good content there as well. And thank you to our sponsors, Serica and BP, for those events. Our annual quiz is Sunday, the 15th of December from 3 till 4. Again, you can register via the website. And that's it, guys. Thank you very much for attending. Really appreciate you taking the time to come today. And please, if you have any feedback at all on the session, we did run over today. I do apologize for that, but some feedback would be very helpful for us to improve in future. So thank you very much. If you have any information at all, if you need any information at all about any events, any materials, any resources, please contact us via our website, and we'll be more than happy to help. So thank you, everyone, and take care.